5,000 or 5,000?
5,000 mooses.
I'm missing one.
So I gave the kids a word problem, and we started with this. There was 5,000 moose, and they're going to double over the next 5 years. Raise your hand if you had it set up like that. Awesome. Now there's another way to set it up where you don't just get given the 2, the base. Instead, they put an E there, which is a 2.718 approximately. They put an E right there, and then they put a power for that. So I think you'll see, I'm just trying to show you that this type of question can be done another way. All right, so now let's say at the end of that time, we really do double the number of moose. Then we could put the 10,000 here, but then we'd have to put a T of what? How long would the time be to make it double? 5 years. In 5 years, then do you get 5,000 times 2 to the 1 is 10,000. Does that make sense to you? So it really will, if you put in a 5 here, this will turn into 10,000. Okay, how about if I do the problem another way? We have 5,000 moose, and the question is, how long till we get 7,000 moose? Same scenario, same exact situation. It's going to double every 5 years. But how long till we get 7,000 moose? You could put the 7,000 here then. All right. Now solve that for T. Pause for a second while you solve this one. And I'm also going to put kids into small groups because the problems today are as difficult as they have been, and it'd be good for them to have somebody to check with. To just make sure you're off on the right start, you should be dividing by 5,000 on both sides. Okay, from here I'd be thinking about a rewrite. I'd cancel off some zeros, be thinking about a rewrite. Okay, and from here, it's just a hop, skip, and a jump to log base 2. And you ask yourself the series of questions. Can I factor it? No. Can I clear the fractions? Well, actually, I could have, but then this wouldn't be alone anymore. So I didn't really want to clear the fraction. I wanted to rewrite. So I'm on a video right now. So we're going to go log base 2 of 7 over 5 equals t over 5. And then that's almost solved for t. I'm going to times both sides by 5. Raise your hand if you followed that. You feel like you got that? Yes? Okay. So then I just figured out the time. This is just a number. Do you get it? Doesn't have any variables in it. Those are all numbers. Even if there was an ln in a problem, it would all just be numbers. You just needed a calculator to get the number if it was a ln, log base e. Okay, then let's get into the regular notes. So for today, we're going to be talking more about exponential growth and decay, but we're going to be doing it a different way. Okay, and it's a way that you have to know, and so we'll do this together. Modeling isn't what the same kind that like Nick usually does on the weekends. This is about actually math models. So focus. So this is an equation right there, that blue line, that I could write for these points. And that series of points just leads us to think that that equation, which is an exponential, so I know it's fundamentally like that, e to the x, but I don't know exactly what that curve should look like, so you throw in like a k right here. Now that's just kind of the basics of an exponential growth, where you can always say it's exponential growth, so it's e to a power. And if I want that power to be like a 2, you can figure out how to make this e to the k be equal to 2. You can say, I just want e to the k to be equal to 2. And then you can solve for k. Would you please do that? If e to the k is 2, what's k? I'm going to pause for a second. All right. Log, and what's the base here? E of 2 equals?
I wrote ln.
Okay. So if you want your number to be doubling, you want your this part here to be doubling, then you can say, I want e to the k to be 2, and then you could solve it, and k must be log base e of 2. All right, so my point is that modeling is where you're writing an equation for a whole bunch of data points that you have, and you can therefore use that to like make predictions. All right, so you can actually make predictions for all kinds of crazy curves, like even this one. You see how that one's going, like, leveling off? And this is world population growth. Do you see how it's kind of slowing down there? Now, there's reasons to think about that, but that could be a long conversation. But okay, so I'd like you to try these 3 problems. They're all kind of simple. One of them is evaluate, which means I just need to know the answer. Is the answer like 2? So figure out the answer. This one, you want to solve it for x, get x alone. There's 2 different ways that would work well on number 2. So maybe try to think of maybe both ways you could solve number 2. It's actually 3 ways I can think of to solve number 2. And then number 3, I'm going to give you this hint. You need to condense. All right. Solve those 3 problems of destiny. Okay, just a quick check. How many of you guys are done with all 3? All right, then I'll pause for a second. If these are problems of destiny, I will use the dice of destiny to see who is going to be explaining them. It's row 1, and it is up the last person. Naomi, can you tell me how to start this one? And you moved what, where, or what did you do? Oh, so you said this whole thing equals 0? Oh, if you said it equal to 0, then you're saying a lie, because all of that does not equal 0. So you can't set it equal to 0. Now, if you wanted to set it equal to something, you could have set it equal to k. Like if I put this in a calculator, that would not equal 0. So you can't just go around saying that's equal to 0. But you can say it's equal to something. And then you could have done your thing with the rewrite. But there's an easier way. Did anybody see something we could do with the 4? Lillian.
You could move it so it's log base 2.
So that 4 goes there. Yes, and then why does that... You must have not just done that randomly, but because it does what?
Then it just simplifies the 3 to the 4.
These 2 are the same. The bases are the same. The answer's already there, and it's 3 to the 4th, and that is the answer.
I told you.
All right. Final answer is 3 times 3 times 3 times 3, and if you do that, is that, and 9 times 9 is 81.
Boom.
All right, nice. Apparently, between the 2 partners, one said it was 81 and one said not. It is 81. Okay, raise your hand if you had that one right. I'm curious. Okay, good. Then, any questions? Do you have a question about why or whatever? I'm willing to talk more. It's because these 2 bases are the same, and you got to know that pattern. That if these bases are the same, then the answer is sitting right there. Question? Anything? Okay, then let's move to this one. Here, I said there was 3 ways. One way is if you had a calculator, you graph y equals that, and you graph y equals that, and the y equals 2 is really easy. It's like that. The exponential is probably like this, but there's going to only be one answer for this because how exponentials look and how a straight line looks, there's one spot where they cross. At least I know there's only one answer. Now, is it possible that there could be no answer? Yeah, it's possible if the lines wouldn't have crossed. But the way I would have probably done it was a rewrite, just the old-fashioned rewrite. But I want a 3rd way. What could I have done that isn't a rewrite? Yes? ln. Add a log, she said. ln on both sides, and then you could have moved this down to the front, and then it would have eventually worked out, but I think the rewrite's probably the easiest way. So I'll raise your hand if your group rewrote this as a log. Okay, good. So then it's log base e of 2 equals 2x minus 1, adding 1 to both sides. Notice I'm not just going to, like, are you stalking me again?
Well, like, yes, but it's
Okay,
still
okay,
not.
okay. I'm gonna put this in a parenthesis, and then I'm gonna divide by 2, or divide the whole thing by 2, like that. There we go. Raise your hand if you had log base e of 2 plus 1, and all of it's divided by 2. Okay,
I
good.
wrote it as like 1/2 log base e.
If you put a 1/2 in front, just be very, very careful, because we are hunting rabbits. If you put a half right there, do you get that you would be missing the 1 at the end?
No, like I rewrote the.
Oh, so you like put a parenthesis around it or something?
Distributed the.
Okay, that would work. All right. Last but not least, we have this one. We're gonna condense these two. Jada, why don't you condense those two for me?
Oh, yeah. So you make it into 1 log by dividing in the argument.
So x over.
2x plus 1.
Yep.
And then I also wrote log base 10 just to make it easier.
I like that, because then you have the base there, and then it's handy right this second, because we're gonna rewrite it again. 10 to the 1 equals x over 2x plus 1. Let's just see how fast Mr. Server can do this without hopefully making a mistake. 2x plus 1. I'm going to do it fast, but I'm going to show my work, because that's what really decreases my chances of messing up. And then I'm going to subtract 20x from both sides. It would have been okay to subtract 1x from both sides, but I'm leaving it so there's something on both sides. Negative 19x divided by negative 19 divided by negative 19. And there, who got to that part? Good. Who went further?
Wait, how did you just? Can you?
Ooh, Sylvia on fire today.
No.
Oh, dang, I thought you had it. Okay, who else? Who knows? Nobody even looked to see if that would work back in the original problem. Can you put a negative right there? No, you cannot. So all that work, and you got an answer, and then you have to label that answer as what? Yes. Don't act like you knew that. You didn't know that. Okay. I know, you were gonna put the pieces together, but I led you there. So I took the lead. Okay, move on to this one. Did you know, you have a question about that one?
Yeah, isn't 10 to the 1 just like 0?
No, 10 to the 1 is 10.
Why am I thinking 10?
So the power of 0 is
Zero is
1.
one.
That's,
That's okay.
you got those
That's-
reversed in your
yeah.
head. That's all right. Keep asking. It'll help clear it up.
I'm like, what?
Did you know that they are finding all kinds of interesting things in ice? Well, as ice is melting, and it's not always because of melting, and sometimes they're just digging deep into the ice and they find things. I saw one the other day. They found a virus that has been frozen in the ice for many, many thousands of years.
Oh boy, pandemic round 2.
Yeah, it's like, that seems like a great idea. Bring that out. We can use something new in the 2020s.
How does that work?
So instead, they have found a flying bison in this case. Of course, that's fake, but they have found woolly mammoth, and there's a chance, they actually is saying in the next few years, there is a chance that they figure out a way to clone that thing and bring it back to life. Yes, seriously, I know. And then,
I really hope they do.
and if that wasn't enough, I can show you if that wasn't enough, I can show you an article where they have taken a chicken and they have crossed it with dinosaur DNA. And we're talking like right now. Like they're still working on this kind of thing. And I know, haven't they watched the movies? All right. So, I want you to zoom in on this formula, and I want you to put end here.
Do we have to memorize?
And nope, you don't have to memorize this one. You have to memorize how to use it, though. Okay, we're going to give you the formula. If this is end and this is start, the start value goes here. The end value goes there. Does that look familiar? Isn't that kind of like what we did before? And what we did before, though, is we would say that it like doubles over the course of 3 years. Well, this one, we're going to use e to the k as our factor. Instead of saying it doubles over the course of 4 years, and you'd like go divided by 4 here, you're not going to do that. You're going to use e to the k as your growth factor. Okay? And as long as k is greater than 0, then you get growth. On the next slide, it'll be the same formula except k is less than 0, and take a guess what happens. You get to k. Okay, so this formula is used for growth when k is greater than 0 and decay when it's less than 0. And take a wild guess what t stands for. No, it's turnips. Okay, of course it's time. All right, so How do we use it? Well, if you gave me a starting value, I'd put it here. If they gave me an ending value, I'd put it there. And if they gave me the time, I'd put it there. And usually you solve for K. That's what we're going to do here. So let's take our flying bison problem that they've dug up out of the ice and brought them back to life by using DNA and cloning and put it inside of an unfortunate elephant, and all of a sudden it grows to be a shaggy, woolly flying mammoth. And I would put my end value here, which was, look, in 44 at year 3. So they just told me two things. They told me the time and the ending value. And they told me the starting value. Can you use all those pieces and put them in that formula? Yes, you can. And then can you solve for K? I hope so. Would you please work with your partner to put this in somewhere, that in somewhere, and then solve for K? Pausing while you try that. Okay, let's see how you did. I'm going to rewrite it one more time to make sure you understand it. It's the end equals the start. And I'm going to use E to be red, K to be blue, and it's always going to be E to the K. Whether or not it's growth or decay, it'll be E to the K. It's just K is less than 0, as in a negative number. Then think about it. If K was a negative number, just for a second, let's say K was -1. Do you get that would make 1 over E, which would be like a fraction, which is why you'd get decay if K was negative. All right, so back to reality here. And I have E to the K. And I was just saying if this had been decay. And so now there's a T, and I'm going to put the T as green here. And now I know some stuff. The end value is 44. So I say 44 equals 14. E, don't know E, but actually I do know E. I just write E instead of 2.718, and the K is unknown. And the T is how long so far? 3 years. And you'd look kind of silly if you say K3. 3K is the way a normal person would say that. Okay, so yay, I've got it, except it's like complicated. What do I do next, Owen?
Oh, you rewrite it?
Not yet.
Not yet?
First, we have to,
Yeah.
there we go.
Yeah.
Divide by the 14. And then, would you please tell me what that simplified to? 22/7. Did anybody have, like, bells go off and go, wait a minute, that's important. 22/7 happens to be the best fraction for pi. 22/7 is basically pi. It is. If you divide it, surprisingly enough, you'll get 3.14. We're not done. I'm just saying that happened to come out to 22/7 means this was probably not just an accident. The teacher was messing around with making that come out that way. All right, E to the 3K. And is it solved yet? No. What do we do? Well, can you factor it? No. Could you clear the fraction? But this is one of those rare moments where you could, but then you'd be right back to where you were in the first place, where you can't rewrite when the 7, if I just multiply by 7 and 7 goes here, that would actually make it worse. So in this one case, clearing fractions would have been bad. Then you go to rewrite. Log base E, yes, that's the same as ln, of 22/7, not a randomly chosen number, equals 3K. And then you put a 1/3 in front of both sides, and 1/3 will cancel the 3, and 1/3 goes here, and that is what K is. Now, the hardest part is to take this next step. That shouldn't have been that bad, but here's the hard part. Now you have to go start with the same equation over again. Start equals, end equals start times E to the KT. Except now we know K, don't we? And now we have a same start value. The start value at year 0 doesn't change. But what does change? So answer this question using this formula, same formula except we know K, and figure out the answer to that. Pause for a second. You put it all together. All right, so let's put the pieces together. So what was the end value? We don't know. We don't know the end value because it's saying 4 question marks. We don't know how many flying bison there are in year 8. So start value though, we do know that. Just look what it says. In year 0, there were 14. So I'm gonna put 14 in the start spot, and I'm gonna put K is this. That's going to go here. All right, and what do I know for time? It says year 8, so you should have put the 8 in here. Now let's just clean it up and write the answer. The end value, which they asked for it in a certain way, so I'll clean that up at the very end, is 14 start value times e to the k, which is all of that stuff. So I'm going to clean it up a little bit. I'm going to put it in as 1/3 ln, I'll just leave it as log base e, that's fine, of 22/7. And that's what the k was, and now I need an 8. If I'm going to times the 8, do you think I should times it by the front of it or the back of it? The front of it. If I'm timesing by 8, here's the place to do it. So I'm going to put that 8 right there. All right. Now, one kid last hour noticed something.
Oh, but you can put the thing at the top and it's just become.
That would go up there.
God. Oh.
Because.
And then
Oh
E,
my God.
E. I didn't even notice that before, so don't feel bad if you didn't notice it. But he noticed that these bases are the same. And so if we move this as a power up there, then all of this just becomes 22/7 to the 8/3. Why? Because E, log base E, is one of those patterns where if the bases are the same, then the answer's right here.
Will we get a calculator this test?
So the end value, they want A of t, meaning if you give them a time, it'll tell you an amount at that time. A of t is 14 times. Now, I would have been fine if you'd have written the other thing. If you would have written this, I would have been fine. The thing in the green box, that would have been okay on the test if you had given an answer like that. So you weren't wrong, but I thought it was particularly cool that the kid noticed that, look at that, the bases are the same, so it can be simplified. All right, we will do more like that. In fact, here's another, it's exactly the same, except k just happens to be negative. Okay, so the thing that's weird in this one is that you're going to feel like you don't have enough info. But because it's called half-life, that means you have half as much in 8 days. You have to understand that they're giving you data there. And as soon as they said half-life, that wasn't just throwaway info. That was like, oh, so you're saying 8 days later, we will have half as much. All right, so use the same equation right here. It's identical to the other one, except they have an A there, okay? And put in the info that you know, and remember, half-life, 8 days. I'll pause for a second while you put in all the info in the right spots. Okay, let's put in the stuff we know. Remember, you start with the end, which is kind of strange, but you start at the end. Do we know the end value? Well, yes, actually, we will.
What?
We'll know the start value was 5, and since it's a half-life, wouldn't it be 8 days later? Half of 5 right there. The end value will be 2.5 because that's half of 5. Do you get how we needed to use that half-life information? If we started with 5, we will have half of that at the end. Okay? And now we have e to the kt. Well, what's k? I don't know. That's the whole point. You're going to try to solve for k. And then what's t? What was the time? 8. So 2.5 is equal to 5 e to the 8k. Would you please solve that for k? K is the constant that's going to tell you exactly what the growth or decay rate is in this problem.
I thought
We knew the time was 8.
we knew the constant was 1/2 because it's a half.
Well, guess what's going to happen when we divide both sides by 5?
It's gonna become 1/4.
No, what's that? 2.5 over 5. It's a half. 1/2 equals e to the 8k.
I haven't done that. I was so close. Think about it.
Now log base e of 1/2 equals 8k. I'm going to divide by 8, or in this case, multiply by 1/8 on both sides. And there you go. I've got k.
Where'd you get 1/8?
By 8.
Yep, dividing by 8. K. So now I've got k. Do you get that now I can rewrite the equation again? Except k is all that. So I'm going to go back to my original. See how I keep going back to the original equation? End value equals start value times e, which we will never mess with because e is just e, to the k t. But now you could tell me any t, and I know that I can just put the k that we just solved, that whole thing right there, right in where the k is. So I'm going to erase this k, maybe move the t over a little bit. And here's 1/8 log base e of 1/2. And so our a of t means it's like short for amount. Does that make sense to you? Our amount at a given time will be whatever the start value is, and we can assume that we start with what they said. They said we're going to start with 5 grams of iodine 131. So we put a 5 right here. That goes up on the rail. It was just too tempting, wasn't it? Times e to the, and I'm going to put the 1/8. I'm not even going to make you do this, but I think it's not a bad idea to say it's log base e of 1/2, and then that 1/8 that was in the front here goes up here. Do you get that's an equation that says I started with 5 grams, and now I have e to the,
Wait, where'd your T go?
you're right, I don't have it there yet, and I'm going to put it in front weirdly. You don't have to. Put it at the end if you want. But why did I write it the way I did? You know what? I'm wrong. I can't put it at the front. I should put it at the end.
Because then it would be raised to the 1/8 T.
I'm so confused.
You know what? I agree. It's going to get too messy. I like this whole simplifying at the end thing, but it's not required. So let's just leave it exactly like that. That's good enough. And we put our K right there, and I'm just going to leave the T here and there. Except our start value, they did tell us in this problem, didn't they? So the start value is 5, so I'm going to put a 5 right there. And now, do you get this as an equation that only has time in it? If you tell me the time, I'll be able to tell you how much you have at the end. See, it's a function. All right, so if I wanted to, I could call it a of t equals 5 times e to the power of 1/8 ln 1/2, all of that, times t. But really, was it that bad? Didn't you just have to put the 5 here because it was the start value? And you just had to figure out k. That's all it was.
On the test, we just leave it like that. 'Cause we don't
Yeah,
calculate.
this is it. All right, let me tell you which problem you should do for your homework. Hey, sit still.
Calm down.
Oh my God, there's
These are the problems that you should do. Hey, I'm not going to make you leave last if you keep doing that. Okay, that is the first problem I want you to do. And that is the only other problem that I need you to do. Do those two over the weekend. That's all I got for you for today.
God bless.